Alright, this is section 8.2. Okay, talk about linear functions. First they talk about green materials sales, and they say in each year it seems to have gone up by 5, and we're talking about billions, so 5 billion more each year. So this is a linear model. So this is a linear function, because as you increase by 1 by 1 by 1, you increase by 5 by 5 by 5. So if the x's are increasing or decreasing at the same amount, and the y's are increasing or decreasing at a same amount, then that makes it linear. Alright? You could think of linear as like buying a pizza. Let's say one pizza costs, I don't know, $15. So 2 pizzas is 30. 3 pizzas is 45. So as you increase the number of pizzas, you increase the dollar amount by 15. So if you add 1 to the number of pizzas, you get 15 more dollars in pizza cost, right? And that's linear, right? So here they're talking about the temperature in a room, and it's getting colder and colder as time goes by. And so after 1 hour, 2 hours, 3 hours, 4 hours, 5 hours, it goes down by 2, down by 2, down by 2, down by 2, down by 2. And so the fact that these are plus 1, plus 1, plus 1, plus 1 the same, and these are minus 2, minus 2, minus 2, minus 2, minus 2 the same, that means this is linear. Alright? And so the numerical representation is this one here. Alright? The graphical representation is that one there. And you can also write it there. Another way, you can write it with a function. And you could write it out in words. You can say that we decrease by 2 degrees per hour. Alright? And so this is what the graph looks like, 80 degrees and dropping down to 70 degrees after 5 hours. Right? So verbally you can write it out in words. Symbolically, now how do you do the symbolic representation? Well, this is f of x equals mx plus b. mx plus b. Now the b here is always going to be whatever you get when x equals 0. When x equals 0, that's your b. So in this case it's 80. Alright? Now what do you get for this guy? Well, this guy is what you have in change here divided by what you have in change here. So subtract 2, so it's negative 2. And here it's plus 1, so it's positive 1. So negative 2 over positive 1. That's your slope. So negative 2 over positive 1 is just negative 2. And that's your slope. So that's your function. Negative 2x plus 80. So you figure out what your b is, and you figure out what your m is, and you plug them in. And that's your line. Alright? So a line has the same rate of change every time. As you keep adding or subtracting from the x, you get a similar change every single time. So now this one says identify linear functions. Well, the linear functions is something x plus or minus another number. So it's negative 3x and you're adding 4. That's a function. That's linear. And this one is just 8. Now it doesn't have a slope here or an x, but it is a function. It's a constant line. It's the line y equals 8. And so it just moves left or right at y equals 8. It's a boring function, but it is a linear function. And this one's x squared, so this one is not a linear function because it's x cannot be squared. X has to be the first power. Now if you're looking at a table, just look at the x values. They go up by 1, 1, 1, and they go up by 5, 5, 5. That's linear. Now here they go up by 2, 2, 2. Here they go down by 2, 2, 2. That's linear. Okay? Here they go up by 1, 1, 1. Here they go up by 1, 2, and 3. No. That is not a function. They should increase or decrease at the same amount. So here they go up by 2, up by 3, up by 5. But here they have the same y value of 7, 7, 7. This is a constant function, y equals 7. That is a line. Alright? Now if you want to graph something by hand, you're going to have to be plugging in different x values and getting corresponding y values, and then you plot the points and you just connect the dots. And now you only need 2 to graph something, but you should do 3. Because let's say you make a mistake. If you do 3 and one of them is off, it'll show up like a triangle and it won't line up nice and neat like this one does. So if you check 3 points instead of 2, it's a good way to make sure you're doing your mathematics right. Now you can use a calculator to graph this, right? As we did before in section 8.1, you can just hit you can hit y equals, and make sure you turn your plot 1 off. Got to go up there and turn it off. So 1 divide 2, and then type in x subtract 2. Alright, now if you want to see what the graph looks like, just hit second window and start with 0 and go up by 1. Okay, it's a good way to start. And second graph gives you your table. And now if you hit just zoom 6, it gives you your graph on your screen there. Zoom 6 gives you a 10 by 10 window, minus 10 to 10, minus 10 to 10 in every direction. Alright. So how do you represent a function? Well, you can represent it by words, you can represent it numerically by a table, or you can graph it. And so words is multiply the input by -3 and add 2. And then the table is this one, and the graph is that one. Okay, and now if you wanted to do that, you could just type in, under y equals, hit clear, and type in -3x add 2. And there you go. And your table, just hit second graph, and there's your table. Alright? So it's real easy using a calculator to do that. Okay, so again, they talk about mx plus b here. The rate of change is the m, and the fixed amount is your b. Right? So they talk about modeling bamboo growth. They say, suppose a bamboo plant is initially 6 inches tall, and they say it grows an astonishingly 2 inches per hour. Some species do. So 2 inches per hour means it starts out at 6 and it goes up by 2 for each hour. So 2 times t plus 6. So 2t plus 6 is your function. Now they want to know what happens at hour 3. Well, 2 times 3 is 6, 6 plus 6 is 12. So after 3 hours, it's 12 inches tall. It's growing very, very fast. Alright? Alright, and then this one was our example that we had before. And you can make a scatter plot of this, right? They want you to let x equals 0 represent 2010. So 2010 is year 0, so 0, 1, 2, and 3 is what you're going to type in. So hit stat 1, and go up and hit clear, come back down, go over, up and hit clear, come back down. Now type in 0, 1, 2, 3. Type in 65, 70, 75, 80. Okay? Oops, I typed them all in the same line. That's not right. So 0, 1, 2, 3. Hitting enter each time. And then 65 enter, 70 enter, 75 enter, 80 enter. Okay? So now hit zoom 9. Oops. We have to turn our plot on, so hit y equals and go up to plot 1 and hit enter. And now hit zoom 9. And there's your graph right there. Okay? Now they want you to estimate a line. Well, it crosses at 0, 65, so 65 is your B. 65 is your B, right there. And we already figured out our slope was 5, right? Because we went up by 1, 1, 1, up by 5, 5, 5. So 5 divided by positive 5 divided by positive 1 is positive 5. So 5x plus 65 is our graph. That's what it looks like. Okay. Now what if you're trying to graph something that is a constant function? Meaning no matter how much time has gone by, you're still driving at 70 miles an hour each hour. Well, that's just 70, 70, 70. Okay? And your slope there is 0 because it's plus 0, plus 0, plus 0 over plus 1, plus 1, plus 1. So 0 over 1 is 0. And so 0x plus 70 is just 70. No need to write 0x because there aren't any zeros. So f of x equals 70. That's your function. And it's a constant function and it's a horizontal line. Right. The midpoint, we don't need to know that one. They don't bother having us learn that. So if you look at putting it all together here. The linear function is mx plus b. And if you plug in a certain x value, you can find a certain y value. And the constant function is f of x equals b, just the y-intercept, whatever it is. And the rate of change is just the slope. It's the difference between the output over the difference of the inputs. And midpoint, don't worry about that. But there's symbolic, verbal, table, or graph. And all of those are different ways to talk about a function. Alright, so let's look at 8.2. These are the similar questions, and we're going to do them in this order here. Let's look at 13. It says determine whether the function is a linear function or not. Well, since it's x squared, it is not linear. You can't have an exponent on the x in order for it to be linear. Determine whether the graph represents a linear function. Yeah, it's a line, so it's linear. No, it is not. It's not linear. Okay. 23. If you go up by 3, up by 3, up by 3, you go up by 1, up by 1, up by 1, that's linear. Yeah. And they want you to find the equation. Well, first off, when x is 0, you got minus 6, so that means your b is minus 6. Now how do we get the m here? Well, it's this number divided by that number. Positive 3 divided by positive 1 is 3. So that's your answer. Now this one goes up by 1, up by 1. This one goes up by 5, up by 20, up by 20. No, it's not linear. They got to be the same increase every time. This one is not linear. Now this one, they ask you to plug in these values into the function. Well, it doesn't matter what you plug in. The answer is always going to be negative 22. Okay? It's sort of like if you ask somebody, do you want to go to McDonald's, and they say Taco Bell. And you want to say, do you want to go to Burger King, and they say Taco Bell. It doesn't matter what you ask them. They're always going to be saying Taco Bell, Taco Bell, Taco Bell. So it's a constant function, meaning the answer will never change. Alright, so now they ask you to graph f of negative, graph to evaluate the given expression. So f of negative 2 is negative 1. And f of positive 4 is negative 4. Okay? And this one, f of negative 3 is 1. F of positive 1 is 1. It's a constant function, 1, so the answer is 1 every time. Now they want you to sketch this, and you plug in 0 into the function, 4 into the function, and 8 in the function, you get this. And so graph 0, 2, graph 4, 3, and graph 8, 4. And that's what your graph looks like. Now, same thing here. If you plug in 0, 1, and 2 into this, and you get these 3 points, and you connect the dots, and there's your answer. Now, this one says, write a symbolic representation or formula that calculates the following. The distance traveled by a car moving at 65 miles an hour for t hours. So the distance traveled, 0 time has gone by, you've traveled 0 miles. After 1 hour, you've traveled 65 miles. After 2 hours, you've traveled 135 miles. So 0, 0 means your b is 0. And plus 65 over plus 1 is 65, so your slope is 65. So 65t plus 0, and you don't need to write the plus 0. Right? Your phone bill in dollars for calling T minutes at 10 cents per minute and a fixed fee of $4.95. So 0 minutes have been talked on your phone, and it costs you $4.95. Now if you talk for 1 minute, it's an extra 10 more cents, so that's $5.05. Add 10 cents to that. 2 minutes, it's another 10 more minutes, 10 more cents, so it's $5.15. Okay, so 0, b, there's your b, right? And then this is your slope. This guy divided by this guy, so 0.10 divided by 1, which is 0.10. Alright? And then this one, it says, make a verbal representation for negative 2x plus 1. Well, you multiply a number by negative 2 and you add 1. Come up with a table from minus 2 to 2 and then graph it. Alright. This one asks you to match the phrase or situation that best fits each one. The cost of college tuition. Well, you'd expect tuition to go up, right? So it's going to be either this one or this one. This is flat, and this one is going down over time. This one says college tuition in 2000 was 0, and we know that's not true, so it's got to be this one for for 79. Now 80 says the cost of 1 gigabyte of computer memory. If you don't know it, when you're talking about electronics, as time goes by, the price goes down. So you would expect the cost of a gigabyte of computer memory to drop over time. 81, the distance between Chicago and Denver. Well, that's a fixed number of miles that they are apart. They're not going to be changing in distance over time, so it's fixed amount. And then 82, the total distance traveled by a satellite that's orbiting Earth. Well, it starts out 0 miles traveled, and then it increases at a certain amount every hour or every day or whatever it is. Right? And so that one is 82. 113, it says, describe the temperature of a room that's kept at 70 degrees Fahrenheit for X hours. So f of x equals 70. It's a horizontal line from 0 to 24, and so it's 0 to 70. And so it doesn't matter what number you input, the output is always 70, and it's a constant function. Okay, 115. Okay, this one shows you, says the car is initially 50 miles south of Minnesota-Iowa border, and it's traveling south. And so here's the Minnesota-Iowa border, and you're 50 miles from it, and you're traveling away from the border. Okay, so you're 50 miles from the border, and then after 2 hours you're 170 miles from the border, after 3 hours you're 230 miles from the border, and so on. All right. So now they ask you to figure out the equation. Well, you know when t is 0, that's your b, so your b has to be 50, right? And now here you're adding 120 and you're adding 2, so 120 over 2 or 160 over 1, same idea, you get 60. That's your slope. 60t plus 50. And this just tells you you're traveling at 60 miles an hour. That's what that really means. Alright, this one says rainforests are receiving more than 70 inches of rain per year. The world is losing about 49 million acres of rainforest each year. Find a linear function that calculates the change in the acres of rainforest in millions in next years. So first off, that first number as to how many inches of rain it receives is meaningless. The number you care about is the 49 million. Right? Now it says calculate the change in the acres of rainforest in millions per year. So in year 0, you have no change at all, so it's 0. After 1 year, it's 49. And after 2, it's 98. So it's changing. It's technically changing at a negative, but they just ask you how much of a change is it, not whether it's a positive or negative change. So 0, 0, 1, 49, 2, 98. And so 0, 0, that means your b is 0. And 49 and 1, that means 49 over 1, m is your 49. So it's just 49x is your answer. Now they ask you what's f of 7. You plug 7 in there, you multiply it times 49, you get 343 million acres is lost after 7 years. Okay, so now this one says the temperature of a gas, if a sample of gas such as helium is heated, it will expand. And so the volume is equal to the temperature times 0.147 plus 40. That'll calculate the volume in cubic inches based on the temperature. Right? So it says evaluate V of 0. We plug in 0 and you get 40. That means you start out at temperature 0 Celsius, you have 40 cubic inches of volume. Now it says what if the temperature increases by 10? By how much is the volume increase? Well, V of 10 is 4147, and we know V of 0 is 40, and the difference between the two is your answer. That's how much it's increased by 1.47. Now they ask you what's V of 100. So you plug in 100 in there and you get 54.7. It says to make a music video it costs $7.50 to rent a studio plus 5 cents for each copy. Write a formula that calculates the cost of producing X videos. So if you make 0 copies of your video, it costs you $750. If you make 1 copy, it costs you the original $7.50 plus $5 for that 1 copy. If you make 2 copies, it costs you another $5 more or $760. Alright, so 0, 750, that means B is 750. Now the fact this goes up by 5, up by 5, up by 1, up by 1, it's 5 over 1 is your slope, which is 5. So 5x plus 70. Now they ask you what's the cost of producing 2,500 videos. Well, you plug that in and you get your answer. right? Weightlifting, they talk about lifting weights can increase a person's muscle mass. Each additional pound of muscle burns an extra 40 calories per day. Write a linear function that models the number of calories burned each day by X pounds of muscles. Alright, so for each pound of muscle, you're burning 40 calories. So X pounds times 40. And so 0 pounds is 0 calories burned. 1 pound is 40. 2 pounds is 80. So 0, 0 tells you B is 0. And this goes up by 40 each time. This goes up by 1 each time. So 40 over 1, that's your M. So M is 40, X, and then plus 0. You don't need to write the plus 0. And now it says, how many pounds must be needed to burn 1 pound of fat? Well, you know that you need to burn 3,500 calories. They're asking you over a 30-day period to lose 1 pound. So divide the 3,500 calories by 30, and that's how many calories you need to burn in 1 day. So if you set that equal to your function, when you solve it, you're telling you need to have 2.9 pounds of muscle needed to burn 1 pound of fat in 30 days. Now it says determine if it's linear, find the formula. Well, f of x equals 1/2 x minus 6, that is linear. M is 1/2 and your b is minus 6. F of x equals minus 9, that is linear. M is 0 and your b is negative 9, that's your constant function.